You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hello, everyone, and welcome to the show.
Hey.
I am really excited to be here. How about you?
I'm so excited. I'm not going to brag, but my topic is a little bit of a twisty, turny journey.
Exciting. Well, you'll have to wait, I'm afraid, because I'm up first.
Yeah.
I actually have a question for the two of you.
Oh,
do you like water?
In what context?
Yes.
All contexts.
I have
like to drink
full
water
bottle right by me and a cup of tea.
You do, yeah.
So, yes.
I like to swim sometimes and wade.
Yeah.
I do like
fair
to
enough,
wade.
Right? That's a terrible inside joke.
You're welcome.
Water is, I think, pretty important to living things here on Earth.
I like being
the Earth's
living.
surface is 71% water, so there's a lot of it. And we record this podcast in Minnesota, which is the land of 10,000 lakes.
We have more than 10,000
and there is
lakes.
water everywhere. I think I may have mentioned this on the show before. My friend Katie, who moved away to Colorado and then came back here to visit, commented on how wild it is, just how much water we have everywhere. Because once she had moved out of the state, you kind of forget that there's just water and lakes everywhere.
It's amazing. You can throw a rock and find a lake or a river or a stream.
If it didn't grow up in a place like that, where water is more scarce, you wouldn't really realize that. But I think being a Minnesotan, I love me some water, and I would say I am drawn to the water. I like canoeing, kayaking, sailing, water skiing, which was invented here.
Yeah, it
swimming, sitting on the beach, just being around water is pretty great. It is, of course, though, dangerous.
Oh, 100%. Respect the water that you are by.
Yes, indeed.
Dihydrogen monoxide, one of the world's deadliest substances.
We'll go down that rabbit hole sometimes, yeah. I was just talking with some of my summer campers about the dangers of dihydrogen monoxide.
Amazing.
And but we won't go into that. Our bodies are mostly water, and we need water to survive. It is particularly incompatible, though, with our lungs.
Yeah.
I can't say this enough. Don't put water in your lungs.
I've done it. Don't do it. Well, it's bad for you.
Especially if you want to breathe, yeah. Now, growing up near all this water, I naturally took swimming lessons. It's important to know how to swim. Many animals can naturally swim, but a lot can't. And for many animals, ending up in water means death, which is pretty wild if you just stop to think about it. Of course it does, right? But for some animals, it's particularly bad. And 71% of the earth is covered in a substance that they will die if they fall into it.
Right.
And if you think about that, it's like,
that's insane.
That's wild.
You'd think most of more animals and living things would be equipped to deal with it.
Able
to swim.
It would be like if 71% of the earth was covered in hydrofluoric acid or something like that, right?
Jesus.
For humans. That'd be bad. And I was thinking this would be really weird to live in such a dangerous world. But here's the thing. Most of that water's in the ocean. And it doesn't really matter if I know how to swim. If you dropped me in the middle of the ocean,
I'm dead.
Or even not all that far offshore, I'm not going to make it. So really,
true.
Water is dangerous no matter who or what you are. If you are a land-based creature, I guess you'd say. So my story this week is about how water, that thing that keeps us alive, can turn into our worst enemy in a terribly horrible way. And it probably isn't what you expect.
Oh.
So this week I'm talking about mermithids. Have either of you heard of mermithids?
Is it the myths of mermaids?
That's what I thought when I
That's
first
what it sounds like.
Yep.
It's a very cool name.
I like it.
And I was really hoping that it was related to mermaids, but I have the sad job of reporting that no. The name has nothing to do with mermaids.
That's tragic.
The name mermithids comes from the ancient Greek word mermis, which basically means rope or string. And myrmithids are a type of nematode that lives in water. And they basically look like a piece of thread or hair that moves in the water.
Okay.
These are related to horsehair worms that you sometimes see in water. If you're some of you may be familiar with those, but they're a distinct group of animals from those. And myrmithids aren't well understood by science because they infect mostly insects. And so the most likely researchers to come across them are entomologists, not nematologists.
You mean insect people don't know what to do with worms when they come across them?
I mean, it's kind of just not not
no,
their
I
thing.
get it.
Not what they study so much.
Not enough legs.
And they are, like I said, they are parasites, so they're found inside insects. They just haven't been studied as much as they probably should be. There has been some research on them though, and they are partially because they're known to infect mosquitoes. And there was some kind of thought like maybe they could be used as possibly like a biological control for mosquitoes.
Oh, okay.
So that's still, I think some of the early stuff they looked at didn't really necessarily work, but there's some people are still looking at it because it's a possibility. And there's lots of different myrmithids out there. So that's all well and good. But how do they make water dangerous? Like that's what I promised, right? Well, you may be thinking that they make water dangerous by making it a place where you can get infected, but that's not the danger I'm talking about.
What do they
today.
exude, Kirk?
Nothing. Researcher and PhD student Usha Mendes was interviewed recently about her work with myrmithids, and it really caught my eye. What she is studying is what happens to spiders in New Zealand when they get infected with myrmithids. Now, I want to be clear. We have absolutely no idea how the spiders get infected. That's part of the life cycle that we still don't understand. I can make a guess. They're probably ingesting some kind of food that has the nematodes in them.
Okay.
And I can imagine some kind of nymph stage of an insect, we don't know which one, is living in the lake. It gets infected, and then it hatches out, it flies around and ends up in a spider's web. And that's, again, probably the most likely route, but we don't really know yet. That's just speculation. Right. What we do know is what happens when the nematode gets into the spiders. It turns them into zombies.
Uh-oh. I also have a zombie parasite topic.
Wait, hold on. You also have a zombie parasite topic?
Yes.
This is crazy.
Oh my God.
Why didn't we save these for Halloween? What are we doing? We're doing like Halloween in the middle of the summer.
Yeah, when this comes out, it's like July.
Yeah.
Okay, sure.
All right, awesome.
Why not? More zombies.
What happens with these particular zombies, essentially, is that when the myrmithids get into spiders, they take over. They physically change the spider's body and its mind. Physically, the spider's legs get shorter and thicker, which is weird.
Oh.
And they can also actually stop eating. And these nematodes start to change their behavior because these nematodes have a problem. The spider is not their final destination. They need to get back into the water, but they're now stuck in a spider on land. So what do? You take control over the spider and turn it into a zombie hell-bent on drowning itself in water. These infected spiders will seek out water and throw themselves in. And that is just bizarre. They do this. And I was like, well, how do you do that? Like biologically, like what is actually going on here? And turns out what they do is they actually change the salt balance of the host, like of their hemolymph. They make it, which is kind of essentially like their blood. They make the salt balance wrong, and the spiders essentially like are in desperate need of water and super thirsty. And so they just like voraciously seeking out water because their salt balance is totally off in their body.
Me in the summer.
Yeah. And so like once the host is in the water, which is the goal there, the nematodes can emerge and be free to begin the next stage of their life. And the spider, who usually can't swim, just most of the time drowns, which is horrible.
That's upsetting.
Yeah,
this is ringing a bell from some other zombie parasite episode we had way back.
Oh, we've had a few.
We've had a few, and they often change behaviors in different ways. Maybe we had ones where like they make you climb to the top of a tree so they can the spores can shoot out of your head and stuff. Like, there's actually one in humans you might be thinking of that makes humans seek out water so that things can burst out of your legs. There's some we've talked about some really horrible things on this show. And like you point out, this kind of thing happens in nature all the time. Like nature is a freaky, wild place. Just imagine if your friend ate something with a nematode in it, and a few weeks later is like, you know what I should do? I should go drown myself in a lake. We should feel very lucky that we don't have to deal with that as humans. So we got a lot of stuff we deal with, but I think we can all count ourselves lucky on that front. That's not a problem we have.
I am very thankful.
Yes,
I like it with not having to worry about that. That's very, very good.
This whole process of having one life cycle in water and another on land is a really common pattern on Earth. Like we see it in things like dragonflies and frogs and mosquitoes. And don't think it's all that strange. Like it's just like, oh, that's what they do. Like frogs start off as eggs in the water, turn into tadpoles, and they hatch out and become frogs, right? But like when the land portion of the life cycle involves being inside of another animal and then like manipulating their behaviors to get you to where you want to be, that's a whole nother step. I think that's what makes it really weird. And
pretty special.
Yeah, this idea that nematodes have found a way to get back into the water by controlling the behavior of animals is the really wild part. And it goes to show that like how with enough time, some pretty amazing relationships can occur. Our planet is old. And just as we've evolved to have some amazing adaptations, like our big smart brain, other animals have had plenty of time to evolve some amazing adaptations as well. They're just different than ours, but kind of equally amazing in their own ways. So next time you see a spider, or maybe just a body of water, think about how complex our planet is and just be glad that your next dip in the water, be it a bath or a surf in the ocean, was completely by your choice and not because of a nematode that turned you into a zombie.
I'm going to think about that a lot more now. Thank you.
Yeah, good. Go enjoy that swim. My source this week was a story in Star News called Zombie Spiders Being Killed Off from the Inside Out.
Thanks. That was awful.
Welcome. All right, we're going to take a little break to help pay for the show here. And although our patrons, of course, you guys don't have to listen to the commercials because that's what you get for being a patron. You get commercial-free episodes. So thank you to our patrons. But the rest of you, we'll see you in a couple minutes. Bye-bye.
Welcome back to the show, everyone. Who's ready?
We're all ready.
So today we're going on a twisty, winding journey. So buckle up. All right?
Yeah.
Way back.
Okay.
I'm buckled into my swivel chair that has no seatbelt.
Amazing. So hold on to it. We're way back in episode 31. Okay. Yeah.
Wow. Okay. I have no memory of that.
I would be lying if I said I remember it.
I talked about the thought in some circles that the story of the phoenix, the mythological bird, came from the very real creature, the flamingo.
Okay? Oh yes, I do remember that.
Well, so I've obviously let things lie long enough from the depths of that episode. And in my ongoing list, I had a topic, and I started to search within that topic, and it didn't quite pan out the way I did, but it led to today's topic. Okay? Now, this is all going to be related, so stick with me. All right? Okay. The phoenix, at that point in time, was the national animal of Greece. Okay?
What
like 2021.
I can already tell this is going to go on a
you're
twisty
welcome.
path,
You're welcome.
like you were saying.
Okay.
So the phoenix was.
This is ADHD in action, folks.
So the phoenix, at least back in 2021, was the national animal of Greece. It is no longer the national animal of Greece. That now is the dolphin. I did double check, and I'm a little sad that they changed it. Because Scotland has remained firm in their usage of the unicorn. So, way to go.
Way to go, Scotland.
So, Greece also is pretty well known for a lot of the myths and mythology and folklore that we know today. We enjoy a lot of retellings. A lot of stories are based on the stories within Greek mythology and in that kind of world. Now, I say that with the knowledge that there's a lot of cultures and a lot of stories that don't get the limelight that they should. One myth that is maybe a little more famous, that is very well known, is the myth of Medusa. Okay? So Medusa, for those of you who maybe don't know, it has a variety of origins depending on the source. Medusa, most people agree that she was a woman who was cursed by the goddess Athena to have snakes for hair and a gaze that turns people into stone, and she became the first Gorgon.
Yeah.
Okay. In mythology, there's a few different creatures across various cultures that can cause petrification, and there's a lot of stories where petrification happens. But we're not going to go down that rabbit hole because that's very much a different rabbit hole. And as common as it seems, true petrification in real life is not that common, which I don't think comes as a surprise to any of us here. The closest that it happens tends to be through certain mummification or ossification and that sort of process. However, and fossilization. However, there is a lake where this process seems to happen naturally. So you brought up water, Kirk, and I went, I'm talking about water today.
Yeah.
Let's go to East Africa in the northern Tanzania along the East African Rift System space. Okay, so this is like southern Kenya, northern Tanzania. Okay. This lake, which was at one point called a Medusa Lake, at least at one point, is now called Lake Natron. Okay. Oh, there's a gas from Victoria. It's
No, I have this or a related topic on my list. It's been there forever.
So this particular lake, it's fed by the southern Iwaso-Niagara River, and it's fed by a lot of mineral-rich hot springs. The lands around it also, because it is a rift system, there was a lot of volcanic activity in that area. So that is going to come into there's a lot of volcanic or previous volcanic activity. It is pertinent to the story where we are going. Okay. Now this lake isn't amazingly huge as in the lakes, especially in comparison to the lakes that I've talked about previously. All right. So it's 57 kilometers long. Also known as 35 miles long, which that's sizable. Okay,
sizable.
It's 22 meters or kilometers, rather, 22 kilometers or 14 miles wide, and those are at the max, depending a bit on rainfall and how much water there is in the region. However, it is a whopping 9.8 feet deep. Okay.
Oh.
So,
wow,
she's a shallow lake. And it's also known that anything that may die in this particular lake the lake will actually calcify their bodies. Okay.
Oh. How quickly does this happen?
I mean, the process, it's not instantaneous. It takes at least a few days to a few weeks. It's not fast. But
Okay, but that's still pretty quick.
So what's happening? Lake Natron is an alkaline lake. It's also known as like a soda lake, and naturally salty. The temperatures
Sure.
around in that area are usually above 104 degrees Fahrenheit, or they frequently get above 104 degrees Fahrenheit or 40 degrees Celsius in the area. So evaporation levels are really high. Personally, that is too hot. I have melted into a puddle. Okay.
Agree.
I'm out.
Fair enough.
So being in a rift, like I talked about, because there was a lot of volcanic activity, there's a lot of minerals that flow and filter into the lake. The lavas that were in the area had high levels of sodium carbonate decahydrate, also known as natron, actually. Like the chemical composition is called natron.
Didn't the Egyptians
They
use that in
did.
mummification?
They
Seems to be
did.
ringing a bell.
Okay.
And they also, the lavas and the leftover rocks had something called trona, which is sodium sequic carbonate dihydrate. Okay? I don't know if you've noticed, I said a lot of words that had the word sodium. So
Sure did.
Yeah.
sodium naturally
I'm
will
thirsty.
make a lake become more alkaline. So the pH of this lake has been found to go up to 12.
Oh,
Oh my god. Oh my god.
okay.
Oh.
Yeah. This is on a scale
Okay.
of 0 to 14,
Wow.
folks. Like,
Yeah, that's
7 is
Mhm.
neutral, like
12.
uh,
12.
water. Yeah.
that's not
So
great.
how's that compared to your household bleach? Or
It's really high.
pretty high.
Really high. I didn't look too much into that because there were some other things about this. That's on its own, that's
Yeah,
already
okay.
wild, okay? Generally, if you have a pH that high, that means that not much will live there. And the
No.
surrounding area
Right?
doesn't have a lot of life around it. For
Life.
good reason.
Yeah.
There's not a lot of water that you can use. But there is some salty-loving algae and cyanobacteria that live in the lake. There's also,
Nice.
we love extremophiles on
Extremophiles.
this show. And there's
Yeah.
also 2 endemic fish species that live there. So that's fun. Seriously.
Seriously?
So there's 2 fish
Whoa.
species.
There was some crazy biology
Right?
going on right there. Okay.
Wow.
It also, which is where I got interested in this particular lake, the cyanobacteria and algae, because they can bloom in such high levels and it's so highly alkaline, the
Mhm.
lake gets a lovely blood red color all
Oh,
over it.
yeah.
So it's a very red water lake.
It's a good warning
I
to stay
mean,
out,
that's
probably,
definitely
right there.
gonna feature in my nightmares. Blood red water everywhere. Ooh, pretty
like The
much.
Shining.
So, like I said, there's not a ton of animals that stop here for water or go find food here. There are people who do utilize this lake in some ways or forms to be able to like get calluses and things off of their feet, like wash your feet, because I mean,
Oh, wow.
it'll
Basically turn your feet
it'll
into
take
soap.
everything off. If you add a layer, don't do it for long. However, if there's not a lot of animals utilizing the space, it does mean that it's a good spot for the largest breeding flock of 2.5 million lesser flamingos who do tolerate these conditions very well because they have very tough scales on their feet. So the total population, 75% of the total population of lesser flamingos breed in Lake Natron in Tanzania.
That's
Wow.
wild. So the red color is
The red
making them
color is
pink?
part of it because they will eat some food there, but they mostly are
The
eating
algae.
from other lakes around them because they're more crustaceans than cyanobacteria, but they do breed and lay their babies here. It's wild.
Fascinating.
So that is my very roundabout turnstile type story this week. There's a
I have whiplash from all the turns. In that
there's
story.
a pretty famous photo actually that made the rounds a number of years ago of like this beautiful like flamingo sitting on top of the lake. It's a black and white photo, and it's not actually on like it was a setup photo. It wasn't actually a fully ossified flamingo. It's a beautiful picture though. Mummified, petrified,
like
dead flamingo.
Dead flamingo.
They were published by
Gotcha.
Nick Brandt as part of his Across the Ravaged Land portfolio. They're pretty cool. But they don't actually turn to stone as soon as they touch the water. But I just wanted to talk about it because a red lake is already weird in the fact that it has such high pH and serves such a huge importance to the lesser flamingo wild. So my sources this week were Wikipedia, A to Z Animals, Live Science, and the Tanzania Safari Club. We are going to take a quick break, and when we return, it'll be Victoria.
Hey, we're back. Well, I already spoiled my topic a little bit, but are either of you familiar with the TV show The Last of Us?
Yes.
Or the video game it was based on?
Vaguely.
I mean, I'm familiar with it.
Yeah, I've not seen this show myself, but
Which I know everyone's going to roast us for. I've stayed up to date enough to know what was going on.
yeah.
That's all I need to
Well, what I know is that it's a zombie TV show, right? But it's kind of unusual in that it's slightly more plausible than most zombie movies because it's based on a real parasitic fungus called cordyceps.
Right. Yes.
So I think in the world of the show, it makes the leap. Yeah. Oh, sorry. Go ahead.
Oh, say that's the one thing I knew about it. That was cordyceps.
Cordyceps. Yes. So cordyceps is a real parasitic fungus that really does make creatures into zombie versions of themselves. I believe in the show it makes the leap to humans.
Yeah.
That's not ever going to happen.
No.
The creatures it infects in real life are ants.
Right.
And as we already kind of discussed, we've covered quite a few zombie parasites on this show, including summit disease, which is a somewhat similar parasite to what I'm going to talk about. But the actual cordyceps is sort of, I feel like it just deserves its own topic here. So
cool.
And I at the end of the episode, I have a little bonus cordyceps related strange creature that was my doorway into this topic.
Ooh.
So let's get started. We know a pretty decent amount about cordyceps. It was first discovered by Western science in 1859. By the superlative Alfred Russell Wallace, who we've discussed a few times on the show.
Amazing.
Dreamy. As we will get into, it's... Oh, Kirk, you want to share something with us?
No, just the guy was living the dream, He was out there exploring the world, finding all kinds of new stuff. Like
that's not what dreamy means, but cool.
I don't have... I mean, okay,
you have a little bit of a naturalist crush on him.
You should.
I a naturalist crush on the man's lifestyle.
I mean, yeah.
Probably not on all the diseases he discovered by getting them himself.
Yeah, he had a tragic life. Anyway,
it was tough. Yeah, go on.
Well, cordyceps is a pretty dramatic and noticeable parasite, at least in its final stages. So I'm sure that Wallace was far from the first person to see it, but, that's the way Western science goes.
I had to
People get all the credit.
write it down.
Yeah. In fact, it actually has been a prized ingredient in traditional Chinese medicine for hundreds of years.
Okay.
So cordyceps is sort of a common name. It covers hundreds of species from 2 different genera. One of the most well-known species is Ophiocordyceps unilateralis,
Whoa.
which is
Oof.
famous for parasitizing ants.
Oh, okay.
Ants from the tribe Campotini, which sounds like a fruity cocktail in my opinion, but so it's carpenter ants.
Oh, okay.
Other species of cordyceps infect other insects, mostly ants and moths. Details vary a little, from species to species, but this is basically how it goes, life cycle wise. Okay, so a fungal spore lands on an ant or attaches to it. It burrows into the ant's body through its cuticle.
Hate that.
Using enzymes and pressure.
Oh, God.
Ugh.
Gross.
Yikes.
Mm-hmm. The ant returns to its nest. At first, nothing obvious happens. However, the fungus is multiplying inside the ant's body.
Of course.
And
Yeah,
soon
of
it
course.
starts to behave oddly. It
What?
has full body convulsions. And these main host ant species, these carpenter ants, live in tropical forests high in the canopy. So these convulsions become strong enough to shake the infected ant out of the tree and onto the ground.
Oh, interesting.
Yeah.
Hmm.
Now it becomes really zombified. And it does what the cordyceps wants, which is it wants it to climb up onto a nearby plant and grab onto the rib on the underside of a leaf with its jaws in a death grip. That's literally what they call it.
Phenomenal.
Yes.
Yeah.
We haven't done that in a while. Go on.
Oh, no.
Okay. As the fungus continues to multiply inside of the ant, it loses any control over its muscles and soon dies. Probably a sweet release at that point.
The sweet release
The
of
fungus,
death.
yes, the fungus continues to grow. It sends its hyphae throughout the exoskeleton of the ant, which kind of strengthens it. And then it starts growing its mycelium out of the ant's body into the leaf that it's attached to, which anchors it even further to the leaf. And then finally comes the fruiting stage, where the fruiting bodies, that's like the mushroom, you can think of it as the mushroom, push out of the ant's head.
What a sentence.
And they're these long tendrils, usually with like a little bulb at the end. So it's this really, if you look at it, it just looks like this weird, desiccated, mummified ant body with these strange things poking out of its head.
Pretty wild.
They then rupture and release their spores, and the spores fall onto the forest floor below. And, although these, you might wonder, like, okay, so the ants live in the tree canopy, the spores are going onto the floor, but the ants do have to descend to the ground because they can't cross certain gaps in the leaf canopy, so they'll come down the trunk if they're moving. They'll go along the floor. So on the forest floor, they can either pick up a spore from the leaf litter, it can cling to them, or it can drop directly onto them from a corpse above, potentially. What's really maybe even stranger, equally as strange, I don't know. Cordyceps likes very specific growing conditions in order to fruit.
Okay. Sure.
So it's not just any leaf. It doesn't just pick any leaf. It picks leaves that are on the northern side of a plant, about 25 to 26 centimeters off the ground. It prefers humidity of 94 to 95% and temperatures between 20 and 30 degrees Celsius.
Oh, that's specific.
Some scientists did an experiment and moved some cordyceps out of this zone, and the fungus was not as successful when it was not in this kind of sweet spot. Also, the death grip was found by a different set of researchers to be synced to solar noon.
What?
Wait, What?
Yeah.
Say more. Say more.
So like when the ant is climbing up and it's hanging out and it's gonna grab onto the rib of the underside of the leaf with its jaws in its final death grip, that happens at noon, apparently.
What?
Yeah.
Huh. That's very specific. You said solar noon, so like.
What?
Huh.
So just like
on the
noon,
north
the
side,
highest point of the sun's arc.
Is this in an attempt to maintain certain those biological conditions that are going to be most successful?
So.
I suppose.
Like if you do it, if it's a good spot at noon, it will be a good spot for the whole day. Basically, I'm guessing.
I guess
that's
very specific.
Bizarre. Yeah.
And so I guess because of these specific conditions, there are particular areas where there are dozens of these dead ants because it's the right place. So they call these graveyards.
As they well should.
Oh my gosh.
They can be 20 to 30 square meters in size, and sometimes the density of ants can be more than 25 per square meter.
Okay, that's pretty good.
Oh, yeah. There is fossil evidence that a parasitic fungus similar to cordyceps dates back to the Cretaceous period. So this has been around for a while. It's thought
Love it.
It thought that it first infected beetles, which spend a lot of time on rotting wood and leaf litter where there's different kinds of fungi. And at some point, the ancestor fungus of cordyceps made the leap to become a parasite. And then as insects diversified, it made the leap at some point from beetles to ants and other types of insects. Okay, so going back, I teased at the beginning that I had a little bonus creature.
Yeah.
Okay, so Alexander Bentley is a herpetologist who leads nature tours in Ecuador. And when he was on a tour last year, he spotted one of these typical cordyceps mushroom stalks peeping from under a leaf. He turned it over to show the group the ant corpse, and to his shock, the object moved.
What?
Oh.
Horrifying.
Okay.
Yeah. So it's like, what's going on? It's supposed to be a dead ant. It's not supposed to move. It turned out not to be an ant at all, but a species of spider, new to science, that mimics the cordyceps fungus.
What?
No way.
Yes.
That's cooler. Honestly, if I got
was it like its legs sticking out instead? Like
instead, if I were to choose being on that particular tour, seeing a dead ant of cordyceps, or a brand new spider, I'm going brand new spider.
Yeah, that's cool. It's pretty amazing. And actually, this guy, Alexander Bentley, helps to figure out that this was a new species by using, I don't know if it was iNaturalist, but some like crowdsourced naturalist website. He posted the picture and people were like, oh no, this is new.
That's so cool.
So the spider looks like a dead infected creature, which I guess is pretty good camouflage to avoid being eaten.
Yeah. I'm not eating that.
Nope. All right.
Oh, that's so cool.
That's what I have this week. My sources.
Thanks for sharing all that.
Yes, my sources were okay. So the New York Times had an article about the spider that was from March 2026. Got some information from Wikipedia. There was an article in the American Naturalist from 2009 called "The Life of a Dead Ant: The Expression of an Adaptive Extended Phenotype." And then an article from the Natural History Museum of the United Kingdom that had a good article about cordyceps.
Oh my gosh, so cool.
And I believe that takes us to the end of our show this week.
It does. How did we go this long without talking about cordyceps?
I don't know.
I mean, they've come up before, but not quite in this way.
Huh.
Yeah.
That's so cool.
They are fascinating.
Thanks everyone for listening.
Bye-bye.
Bye-bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.